Alrighty, so for this video, we are going to do a couple of examples about end behavior. You should have watched the first example that described the main idea of what end behavior is, and now that we're here at this next lesson, well, it's the same lesson, it's just some more examples. So this is just for us to really solidify this topic of end behavior and make sure we really know what's going on. Also, I want to teach us what limit notation is. So that's the first thing I'm going to talk about. So we have something called limit notation. Okay, this is really the way I would prefer you to write your end behavior. Okay, so this is your mean girls moment right now. For those of you who know what I'm talking about, in terms of like the limit does not exist. I don't think that's going to be an answer to any examples in this one, unfortunately, but we are still talking about limits. So there you go. You will actually know what Mean Girls is talking about after this lesson, okay? So I want to show you how to write each of these answer choices, A, B, C, and D, in limit notation. So A says, as x approaches infinity, f of x approaches infinity. So how I'm going to write A in limit notation is the limit of f of x as x approaches infinity equals infinity. So A and A are exactly the same. This is how you write it in limit notation, which is the way I would like you to write it in. So this says the way that you read this is the limit of f of x as x approaches infinity equals infinity. Okay? Now, if we do, I want to do B, part B in limit notation. B says as x approaches negative infinity, f of x approaches infinity. So to rewrite that, I always start with the limit of f of x every time. And then I need to talk about what x approaches. Part B says x approaches negative infinity. So this is as x approaches negative infinity, my limit, part B says, is infinity. Okay. Again, I'm just rewriting A through D. I'm not like solving anything here, okay? Part C, let's rewrite. That'll be the limit of f of x. Part C says x is approaching positive infinity. So as x approaches positive infinity, my limit is negative infinity. And last but not least, to write part D in limit notation, we have the limit of f of x. This one says as x approaches negative infinity equals negative infinity. Okay, so that is how you write those in limit notation, which is the more accurate, more correct, more mathematically sound way of writing your end behavior. Okay, so that being said, let's do some examples together. We had one in the previous video. Now we're going to have several more so that we can really drive this topic home. So let's take a look at number one. We need to think about as x approaches infinity, so as x goes to the right, what is happening to the y's? Well, my arrow is going down. So as x approaches positive infinity, my function is approaching negative infinity. Okay, so this would be answer choice C. Okay, but we also have to see the other direction. So I also need to go the other way. As x approaches negative infinity, my arrow is still going to negative infinity. Okay, so also D. All right, moving forward. Example 2. As x approaches positive infinity, so as we go to the right, my y values are going up. So positive and positive, that's A. And now we have to go the other direction. As x approaches negative infinity, aka to the left, my y's are still going to positive infinity. So we have negative and then positive. So that's answer choice B. So A and B. All right, example 3. As x approaches positive infinity, my y's are approaching negative infinity. This is tricky, but we're looking at the right side. That's why I'm looking at this right arrow. So as x goes right, y goes down. So positive, then negative. So that is answer choice C. And then lastly, we need to figure out the other way. So as x approaches negative infinity, that's this arrow. So my y's are going to positive infinity. So negative and then positive, that is B. Okay? So those are some examples using limit notation and just some more practice on end behavior. So now we have examples 4 and 5. These are not in limit notation. I'll give it a pass this time since it's already printed. But we do need to know how to write it in limit notation as well, okay? So looking at number 4, I need to know as x approaches positive infinity, well, that's my right arrow. So y is also approaching positive infinity. So to fill in my first blank, as x approaches positive infinity, y also approaches positive infinity. Okay. And the next one, as x approaches negative infinity, because we have to go both ways, that's my left arrow. So y is approaching negative infinity. So my second blank is going to be negative infinity, negative infinity. Okay. All right, example 5. This one is tricky. So we start the same way. I want to know what happens as x approaches positive infinity. Okay. So in one sense, we have some y values going this way and some going this way. Okay, so that's not really working for us. We can't have both going in different directions. So really what end behavior is saying as x goes to the right, where are all of my y values headed towards? Well, they're headed towards right here. They're all approaching this line right here. And this line is at y equals -4. I know this is kind of tricky to think about, but as we are going to the right, all of my y values are ending up, they're trying to approach, get to -4. Okay? So to fill this in, we'd say as x approaches positive infinity, my function is approaching -4. Okay, so now let's go the other direction. As x approaches negative infinity, well, my y values are still approaching -4. They're still both hitting at this line right here, okay? Because they're going in opposite directions, but they're both going right here at -4. So it's still negative infinity approaching -4. Okay. Now let's go over to the back side. We have 3 more examples because we're not going to do 9 and 10. And we're going to practice writing these in limit notation. So for the first one, I first want to know what is going to be the limit of f of x as x approaches infinity. Okay, so as x approaches infinity, my y's are also slowly but surely approaching infinity. So this is infinity. And then I need to go the other direction. Okay. So we have as x approaches, but wait a second, we're not actually going to approach infinity on this one because our x values are stopping right here. This is called an asymptote. It means it's a place where the graph cannot go past. So we have an asymptote at x equals -4. That's asymptote, which we'll learn more about later in the year. But because my x cannot physically approach infinity, we have to say, well, x only approaches -4. So I would write it as the limit of f of x as x approaches -4 equals, well, once I get to -4, my y's are still going down to negative infinity. So that's still negative infinity. Okay, so that one was tricky. All right, example 7. I have the limit of f of x as x approaches infinity equal. So as x approaches infinity, that's this arrow over here, my y's are going to negative infinity. So it's going down. And then we go the opposite way. As x approaches negative infinity, that's my left arrow, my y's are approaching positive infinity. Okay, so to write it in limit notation, that's the limit of f of x as x approaches negative infinity equals positive infinity. All right, and last but not least, number 8. Let's take a look. First, I need to think about what happens as x approaches infinity. Well, that's my right arrow, which is indeed approaching infinity as well. So that is the limit of f of x as x approaches infinity equals infinity. And if we go in the other direction, as x approaches negative infinity, my y's, they're going down, but they stop here at this point. We have another asymptote situation. This graph is incredibly hard to read and blurry, but just trust me, this is at y equals -7. It's another asymptote. Okay, so yes, it's going kind of down, but it only goes to -7. So instead of approaching all the way down to negative infinity, we only get to go down to -7 and we have to stop. So this one is going to be the limit of f of x as x approaches negative infinity equals -7. Okay, and we're going to skip the last two because it's incomplete. So that's it. So hopefully this helps clarify end behavior. And yeah, that's it.